The classwork is posted. Today we're talking about classwork 6.05,
All right, y'all.
which is arcs, chords, and tangent lines. The classwork is posted. Today we're talking about classwork 6.05, which is arcs, chords, and tangent lines. Talking about arcs, chords. All right. Not very tough and not very hard subject to talk about. All right. Just have to remember not very tough. First we're going to finish up with some arcs and arc and chords and proofs. Just have to remember rules. Just two things we have to talk about. Finish up with some arc and chords. The first thing is with that congruent just chords. Two things we have to talk about before we get into it. The first thing is that congruent chords have congruent arcs. All right, congruent chords have congruent arcs. Okay, congruent chords have congruent arcs. And conversely, congruent arcs have congruent chords. What does that mean? Congruent chords have congruent arcs. Real quick. And conversely, congruent arcs have congruent chords. What does that mean? What that tells us is this right here. This arc here. Nobody make fun of my circle. All right. If I tell you that these two arcs tells us is this right here. This arc here, congruent in measure. If I tell you that these two arcs are congruent. All right. Congruent in measure. Means is these two chords, are congruent in measure. All right, are congruent in measure. What that means, that's what is these two arcs have congruent. Congruent chords have congruent arcs in measure. If these two chords are congruent, that's what these two arcs are congruent. Have congruent. Congruent chords have congruent arcs. The second thing you have to remember: these two chords are congruent. These two arcs are congruent. Then that means these two chords are congruent. The second thing you have to remember, and conversely, if these two arcs are congruent, then that means these two chords are congruent. The second thing we must remember between parallel is arcs, chords. Between parallel are congruent as well. Chords. All right, arcs between parallel chords are congruent as well. All right, and it's a reason for this. It's a reason for it. All right, arcs between parallel chords are congruent as well. All right, and it's a reason for this. It's a reason for it. Okay, so here's an arc here. All right, boom. An arc here. We'll call this AB. Okay, we'll call this one CD. Here's an arc here and an arc here. We'll call this AB. If I say that we'll call this one CD. Chords. If I say that chord AB is parallel to chords CD, then that means if I say that chord AB is parallel to this arc right here, arc BD, then that means will be congruent to arc AC. That this arc right here, arc BD, so again, will be congruent to arc AC. If AB is parallel to CD, so again, then if AB arc parallel to CD is congruent to arc BD. Then, arc AC. Now, so why is that? Well, watch this. If I was to cut this by transversal, now, that would mean why is this angle and this angle? Watch this. If I was to cut this by transversal, that's why these arcs. That would mean that this angle and this angle are alternate interior angles. Just a little proof why these arcs, just so you can understand why things are what they are. So just a little proof on that. So now, going into the examples that we why things are what they are. Examples, you'll see they're not really solve this problem. They're more the examples that we put here. That something is the examples what it says it is. They're not really solve this problem. They're more. Let's talk about the that something is what it says it is. Okay. So now let's talk about the examples. For example, one, it tells us to prove. Now. For example, BE, it tells us is to prove DC. There's some things we need in order to be able to prove that. Okay, so here we're going to draw the circle. I'm going to draw the one that's on your worksheet. There's some things we need in order to be able to prove that. Okay, so here we're going to draw this circle. We have a center at A. All right, and then we got two diameters going through that. We have a center at A. Here's one of them. And then we got two diameters going through that. Okay, here's one of them. Okay, here's another. So here's center A. All right, this is B. That's D. Okay, this is so here's center A. And that's C. All right, this is B. All right, that's D. So this is what's given to us, and they're asking us. C. Watch this, because it's not drawn in here, right? So it's not drawn. They're asking us to prove that this chord. It's not drawn in here, right?
It's not drawn.
They're asking us
equal to this chord
to prove that this chord
BE.
That's what they're asking us.
Will be congruent.
The three things we look for. First thing we look for are any angles going to automatically be congruent.
Okay.
Now there's three things we look for.
A couple
First
of
thing we look
types
for
of
are
angles
any
that are
angles
automatically
be congruent.
One of them being
a couple of types of
yes,
angles that
it,
are automatically
vertical
congruent.
angles. And if I can
one
prove
of them being
that vertical angles are
yes,
congruent,
you guessed it. Then that starts me off in this process of proving
that vertical
whether
angles
these two chords are congruent.
And
then
yes,
that starts me off in
here's
this
a vertical
process
angle,
of proving
and here's a vertical angle.
whether these two chords are congruent.
Just like this is a
and
vertical
yes,
angle, here's a vertical angle, and here's a vertical angle.
All right,
Just like this is
a
vertical angle
on the vertical
and this is a vertical
that have
angle.
the chords coming, that have the chords in there. Okay,
all right,
so
but I'm
going to focus on the vertical angles
so I
that
can
have
say
the chords coming.
The angle B,
that have the chords in
AE.
there. Okay, so these are the two vertical angles I'm going to focus on.
So I can say that angle BDAEC is congruent.
Why?
Because they are vertical angles. DAC. Right? Why? Because they are vertical angles.
So that's the first part of proving this. Then I look for, okay,
so that's the first part.
Are those vertical angles central angles?
All right. Central angles,
angles are angles.
Are those vertical angles
central
on the center
of the circle?
All right.
And I
central angles, remember,
central angles are angles whose vertex is on the center of the circle.
AE,
right? And I look
is a central
angle
angle.
BAC.
Why do I
need
these
to these
AE
central angles?
Because
that
central
means
angle.
Why do I need
angle
these
BAE
these central angles? Because that means
the measure of angle BAE is equal to the measure
BAE
of arc B. The measure of angle BAE is equal to the measure of arc.
Just like
angle
B
DAC is a central angle. All right. Just like angle DAC.
And what does that mean?
That is a central angle. Angle DAC is equal to the measure
what does that mean?
Arc D. That means the measure of angle DAC is equal to the
so
measure
I can say
of arc D.
That this arc right here
is congruent to this arc.
So
right
I can
here.
say that
the rule
this arc
said
right here
is congruent to this arc
these
right here.
arcs are congruent,
and the
what
rule
does that
just
mean
said
for their chords?
that the chords are congruent.
That if these arcs are congruent,
that third step,
what does that mean for their chords?
Because
that the chords
arc
are
BE
congruent.
is equal to arc
that
third
DC.
step is because arc BE then is equal to arc DC. Chord BE must be equal to chord DC. Then BE chord BE must be equal to chord DC.
So again, three things we look for: angles that are congruent.
We just proved that.
Vertical angles. We look for vertical angles. So again, three things we look for:
we would look
angles
for
that are
alternate
congruent.
interior angles if we
So
have parallel
vertical
lines.
angles.
Here we have vertical angles.
So boom, we're good.
All right.
Or we would look
then
for
we
some
look for
alternate
central
interior
angles. If we
Are
have
those angles central angles?
Here we
Yes.
have vertical angles. So
Why do we
boom,
look for the
good.
central angles?
Then
Because
we look for central angles.
Are those angles central angles? Yes.
Central
Why do we
angles
look for
and
the
arc
central angles?
and their
Because
intercept arcs are congruent.
central angles tell us about arc measure.
All right, central angles,
Central
and
angle
arc,
BAE
intercept
intercept arcs are congruent.
So that is congruent. All right,
BAC,
central angle BAE
intercept
intercept
arc
arc BE. So
and
that is
if
congruent.
I have congruent arcs,
DAC,
that means these chords
intercept
right here
arc DC
must be congruent as well by
And
rule. If I have congruent arcs, that means these chords
we're gonna
right
keep this
here
lesson moving.
must be congruent as well.
We're going to
by
go to
rule.
example 2 now. Number 2.
Okay. All right, we're going to keep this lesson moving.
And these notes are nice.
We're going to go to example 2 now.
All right.
Number 2. Example 2.
These notes are nice.
All right. Example 2. Okay. It says find the measure.
Okay.
It says
Of
find
arc BD.
All right. So we have
The
a circle
measure
here, and in this
Arc
circle,
BD.